Welcome to our second workshop. This is Chemistry 1405. This is going to be a workshop over conversion factors and dimensional analysis. Now this workshop will primarily focus on problem solving, but we also will go a little bit into the theory of it, just because I think it's important to have an understanding of what dimensional analysis and conversion factors are. So you might have heard the word dimensional analysis in class, and all dimensional analysis is, to put it in simple terms, is converting between units using conversion factors. That's all it is, basically, using conversion factors to convert between units. And so what is a conversion factor? A conversion factor, basically, it's a fraction where the numerator and the denominator, the top and the bottom of the fraction, represent equal amounts, or at least related amounts, but in different units. So let's take a look at what would be an example of some of these more simple examples. So for example, we know that anything you can set equal to something else, you can use as a conversion factor. So we could say that, for example, 12 inches is equal to 1 foot. And because 12 inches is equal to 1 foot, I could write this as a conversion factor. The conversion factor would look like this. I could either put 12 inches on top, 1 foot on bottom, or, and forgive me, this may probably is a little bit of a review for you, something you've already seen, but so I'll be quick about it. For 1 foot, also equal to 12 inches. And because the top is equal to the bottom, it doesn't matter which is which. You'll choose one conversion factor over the other based on what you're starting with. The unit that you start with has to cancel out. So that's essentially what you have to do. So that's a simple example of a straightforward conversion factor. Okay. However, there are it might be called situational or conditional conversion factors. This would be like, for example, something that's not universally true, but something that may be true for a particular case. So, like for example, if you have a density which is 1.25 grams per milliliter, anytime you have a fractional unit like that, grams per milliliter, it always means grams per 1 milliliter. So I can write that like a conversion factor. I can use that density as a conversion factor. Let's see. Where is it? There we go. Okay. So I could write this as 1.25 grams and have 1 milliliter on the bottom. I could have 1 milliliter on the bottom and 1.25 grams on top, or rather 1 milliliter on top and 1.25 grams on the bottom. Either one of these is a valid conversion factor, but it just depends on, you'll use whichever one is appropriate to what you're starting with and what you're trying to convert to. Okay, so this is an example of some conversion factors. So we're basic, and the key idea here is this. Because conversion factors are fractions that are equal to 1, you can, or when you're trying to solve for a problem using dimensional analysis, you're not actually changing the amount. You're simply changing how that amount is expressed. Because conversion factors are basically like multiplying by 1, since the numerator is equal to the denominator. So that leaves us with this very important principle, and I'm going to bold it and italicize it for this. In dimensional analysis problem, problem, you must start with a value, in other words, a number or measurement, that is in some way equal to what you're looking for. In a dimensional analysis problem, you're always going to start with what is in some way equal to what you're looking for. Okay, so with that basic framework, let's tackle a kind of a practical problem. Let's say, for example, you have to plan a pizza party for your office. This is problem number 1. If 45 people are coming to the party and they eat an average of 3 slices of pizza or pieces of pizza per person, how much money will it cost to buy pizza for the party? Each pizza has 8 slices and costs $8.50. Okay, so when we're looking at a problem like this, we typically want to look at the question of the problem as how much money will it cost to buy pizza for the party. Okay, here you go. So how much money will it cost to buy pizza for the party? I'm looking for the total cost. Well, the total cost is going to be equal to or determined by what? What value am I going to have to start with? It's not a bad guess. You might think, well, $8.50, the cost of the pizza is going to determine in part how much money it costs. But see, here's the thing. If you're buying the pizza from the same location and you're going to get the same deal no matter what, the cost of the pizza doesn't really determine the total amount of money it costs to buy pizza for the party. So what might actually determine the total cost for the party? Well, in this case, yeah, the 45 people. So 45 people. So I'm going to go ahead and insert that. So 45 people are coming to the party. I'm going to go ahead and reset this up. So now here's another important point with conversion factors. Whatever unit that you start with, or whatever unit's previously up top, it has to cancel out. So the only way to have this cancel out is to divide by it. So I'm going to put people or person on the bottom. What can I relate to people or person? Is there anything in this problem that relates to a person? You got it. 3 pieces of pizza per person. So that's what relates to person. So 3 slices or 3 pieces of person, or 3 slices of pizza for 1 person. I'll just go ahead. Ooh, well, what did I do? Okay. 1 person. 3 slices of pizza for 1 person. Okay. So next, person has now canceled out. I'm still trying to find the cost. I'm not there yet. And so what unit is going to have to come on the bottom? Well, the same one that was previously up on top. Slices of pizza. And what can I convert slices of pizza to? What can I convert slices of pizza to?
Person?
Yeah. Oh, wait, what did you say?
A person.
I could relate slices of pizza to a person, but see, I've already used that conversion factor here. So that would be going backwards. That would just kind of set me back to where I was before. But that is
Oh.
true. How could I move forward? What could I convert? What slice is related to?
Mm, must when we cross to the so it's a A slide. Mommy.
Yeah, and 8 slices is equal to one
Yeah.
pizza, right?
Yeah.
So one pizza is 8 slices. Okay. Well, that helps me. I have pizza. I'm still trying to get the total cost. So I will go ahead and continue. All right. Now what unit's going to have to go on the bottom this time? What do we think? What unit has to go on the bottom now? The bottom of the next conversion factor.
It's some money.
Well, okay, so I want to distinguish between two things. So every measured value is composed of two parts, a unit and a number. So the unit, like for example, with the 45 people, the unit is people, okay? The unit would be people. The number is 45. I want to focus on units first because from my experience, students always seem to make the most mistakes when they start putting numbers before they put the units. So based on what we've already done, let me go ahead and hit my marking pen. Based on what we've already done, people has canceled out. People, person. Slices of pizza has canceled out. Slices. What unit is going to have to go here on the bottom? What unit needs to cancel out now? Because remember, we're trying to get the
Pizza.
cost. Yeah, pizzas, right? So I'll go ahead then and I'll put pizza on the bottom here. So I'll do pizza. And what can I convert pizza to?
It's one pizza. The on the top.
Yeah,
On the top, it's gonna be $1.
yeah, exactly. It's going to be dollars. So, and specifically, as I think Jonathan mentioned, it was 850,
Yeah, 850.
850, $850 per pizza. Okay, so then now we are done. Now we can actually calculate this and determine what the cost of the pizza is.
So we get the 45 times 850.
Mm-hmm. Well, it's going to be 45. We have to actually multiply everything on top and divide by everything on bottom. So it'll be 45 times 3 times 1. And of course, you can skip the 1 times 850. And then I have to divide by 1. Of course, you can skip the 1. Divide by 8. Divide by 1. So essentially, it's 45 times 3 times 850 divided by 8.
So it's gonna be 143.3.
Mm-hmm. Yeah. And in this case, let's see. You said 143 point what?
Point 43.
Okay, 143.43. Now, admittedly, this would be the cost if you could buy pizza by the slice, but if you're only buying whole pizzas, you might actually you might actually have just stopped right here, figure out how many pizzas it would be, and it turns out that it would be about 16.85 pizzas. You'd round that up to 17, and 17 times 850 would be 144.50 if you went by the whole pizza. But that's basically the idea. That's basically the idea. So there's a consistent pattern. Whatever is previously up on top is going to have to come down on the bottom to cancel out. And you continue that pattern until you get to the unit you're looking for. In this case, the cost, the dollars. Does that make sense? Any questions on that one? Cool. All right, so let's go ahead and take a look at the next one. So Drew jogged 15,840 feet in 45 minutes. How many miles did he jog? So for this question, keeping in mind I want to start with what's equal to what I'm looking for, in some way equal to what I'm looking for. I'm looking for how many miles he jogged. So what am I going to have to start with here? Yep. So this is going to be, I'm going to start with 15,840 feet. And then I'm going to go ahead and, okay, so this is feet. Sorry. And feet's going to have to go on the bottom. And I'm going to convert to miles up on top. Okay. So now you'd ultimately have to look up in a table for miles and feet if you didn't know it offhand. But essentially 1 mile we know is going to be 5,280 feet by definition. And I don't think your professor would actually expect you to memorize this. This would be something that would be given to you. Now question, do I have to do anything else? For example, what do I have to do with this 45 minutes? Well, it turns out that you don't have to actually do anything with it. A lot of times you're going to be given problems where you'll be given extra information that's not necessary, and you have to be able to identify whether or not that information is going to be useful or not in solving the problem. Um, most of the time, the information in the problem is necessary, but on occasion, you'll get stuff that isn't necessary, and you won't have to use it in the problem. Cool. So actually, and just as a bonus gift for y'all, I'm going to actually share a this is a table of conversions that I made that has all of the metric conversions and also a lot of the English ones. So if you click on that, open it up, it'll have all the metric conversions, and then it'll have the English abbreviations, English unit conversions, and a few of the English to metric conversions. Chances are you won't necessarily be expected to know the English conversions or the English to metric conversions, but you will, in all likelihood, be expected to know at least some of the SI prefixes. But we'll go over those. All right, let's take a look at the next one. Well, actually, we can solve this one. 15,840 feet and 5,280 feet. So the answer, putting that into your calculator, it comes out as 3. But would I write the answer as just 3? Or would I write it as something else? What do you think? How many significant figures should be in my answer? And that's actually not a bad guess. But here's the thing. If we look at the number of so whenever we use conversion factors, we have to determine if they are measured or exact numbers. And this kind of goes back to our workshop last week with significant figures. So measured numbers would be like this, the 15,840 feet. That's a measured number. It is something that had to be measured because of the person who jogged it. However, if I see 1 mile or 5,280 feet, you might think that's a measured number, but in actuality, it is an exact number. The reason is because it's a definition. By definition, 5,280 feet is equal to a mile. So nothing was measured there. And since these are exact numbers, exact, then that means that they have unlimited significant figures. infinite sig figs, okay? So the only significant figures that I really need to worry about is the sig figs and the first number I'm starting with. And if you look at this first number, the 15,840, how many significant figures is that? How many sig figs is that? Very close. You might think that the last zero is significant, but the trailing zeros at the end, are only significant if there's a decimal point. In this case, there's no decimal point, so this is actually only 4 significant figures. And because this is 4 significant figures, my answer must also have 4 significant figures. So I would end up writing this as 3.000. In this case, these trailing zeros are significant because there is a decimal point. It's 3.000 miles. Does that make sense? In general, most times the conversion factors you're going to be dealing with are going to be exact numbers, and therefore usually the significant figures you start with is the significant figures you end with. Okay, so let's take a look at number 3. So for number 3, it says Tori measured a beetle in biology. 2600 micrometers long. What is the length of the beetle in millimeters? So in this case, I'm going to go ahead and insert, whoops, don't want an equation there. I'm going to put it down here. Go ahead and insert an equation. All right, so this one is very obvious. There's only one number, so that's what I'm going to have to start with. And micrometer, micro is this goofy looking cursive U type letter. It's a Greek letter, and this is what it looks like. And it's essentially, it's actually the Greek letter mu, kind of like the equivalent to our M, but it looks like a cursive U. But micrometers has this very specific meaning. If you look at that table of conversions, you'll see that micro means 10 to the negative 6, or 0.000001. That will become important in just a second. So I'm going to start with this. I'm going to go ahead and multiply by conversion factor. And the unit that's going to have to go on the bottom is going to be my micrometer unit. What am I going to put on top? What can I convert micrometers to?
Millimeter. 1
I mean, you might
millimeter.
want to go ahead and try to convert micrometers to millimeters, but the problem is I don't know what the relationship is between them. So you want to see the micro in the table, in the conversion table, that relationship or that meaning of 10 to the negative 6 only works for comparing micrometers to meters, and likewise with the millimeters. Now, if you're really sharp in math, you can figure out the conversion, what the relationship is between millimeters and micrometers. But in general, it's safer here to convert to the base unit. In general, when you have a prefix unit and a base unit, you want to go, or when you have a prefix unit, in this case micrometers, that you're trying to convert to a different prefix unit, in this case millimeters, it's usually best to go through the base unit. Now I just used some different terminology here. The base unit is the unit that tells you what type of measurement it is, in this case meters. Meters is a unit of measurement representing length. However, micro is not specific. Micro is not specific to any particular measurement. You have microvolts, you have microcoulombs, you can have micronewtons, you can have micro just about anything, microseconds. Micro is just a prefix that's stuck on the end of other units to kind of classify it. So this micro is a prefix, and the base unit is the meters. So what I usually recommend to students is that when you're doing a conversion from a prefix unit to a base unit, go ahead and put a 1 in front of the prefix unit. Put a 1 in front of the prefix unit. And then put the meaning of the prefix in front of the base unit. Ah, I need to get that off. No problem. There you go. Put the meaning of the prefix in front of the base unit. Now, as I mentioned before, the meaning of micro is 10 to the negative 6. Or 0.000001. You can use either one. Now, of course, that doesn't get me to my final answer because I'm still trying to find millimeters, right? So I'm then going to have to do another conversion. And what unit's going to go on the bottom of this second conversion? What's going to go on the bottom of the second conversion? Yep, very good. Excellent stuff. Meters. And what am I going to convert to? What's going to go on the top? What unit? Well, I'm not looking for centimeters.
Millimeter.
Millimeters, yeah. I can see why you'd think to go to centimeters. Might think that, well, that's the next one up. But in this case, no, we're actually going to go from meters to exact. We can go to a base unit, from a base unit to any prefix unit, and we're going to want to go to the one we're looking for, millimeters. Once again, I'll put a 1 in front of the prefix unit. Here's a point of reference. Here's my base unit, and there's my base unit, but one of my units has a prefix. I'll put a 1 in front of that. And then the meaning of the prefix goes in front of meters. And what does milli mean? What is that number that I should put in front of meters?
Is that 10 exponent 3?
10 to the negative third, yeah. Milli, if you look at that prefix that I
Milli
gave you.
to mil.
Exactly. So milli is going to be 10 to the negative third.
Yeah.
There you go. Excellent. That's exactly right. So milli is going to be 10 to the negative third. And then you just go ahead and multiply everything on top and divide by everything on bottom. Now, I will say this. You may have seen your professor do something like, well, 1,000 millimeters in 1 meter or 1,000 milliliters in 1 liter. That's perfectly fine. You can do that. The only hesitancy that I have about recommending you to use 1,000 millimeters is equal to 1 liter is that even while that is true, kilo, the prefix that means 1,000 is kilo. So 1,000 meters is equal to 1 kilometer. If you're using two different prefixes that both, and you're using 1,000 for both of them, and you're switching from using the prefix unit to the base unit or whatever, you could start to get confused pretty easily. I found that one thing that helps my students to keep from making mistakes is to always use the meaning of the prefix and also to put a 1 in front of the prefix unit and the meaning of the prefix in front of the base unit. Also, it helps with memorizing what each of those prefixes are, because then you're not caught using 1,000 for both milli and kilo, because milli actually means 1/1000th or 0.001. Kilo means 1,000, 1000. So those are very different things. So I multiply everything on the bottom and I multiply everything on top, divide by everything on bottom, you should get 2.6 millimeters. A pretty small beetle. Cool. Any questions? Does that make sense?
Yes.
All right. So let's go ahead and take a look at number 5. So this is more along the lines of pharmacology type problems. And you're going to actually see pharmacology problems come up on the HESI and some other nursing exams. I don't know if any of y'all are interested or pursuing anything related to that, but um, it's also useful for other things as well. But let's take a look at this next question. It says a vial of medicine contains 3 centiliters of liquid. One dose of the medicine is 5 milliliters. How many doses of medicine are in the vial? So in this case, the question is asking how many doses of medicine are in the vial. Okay? If that's the case, what am I going to start with? What value? What am I going to start with? 3 centiliters. Absolutely. Because I'm looking for the medicine in the vial. So what do I start with? The volume of the vial. This is equal, the vial's volume is equal to the doses of medicine in it. In some way. We got to figure out what that means mathematically. So centiliters, C is centi, L is liter, so centiliters. And then I'm going to go ahead and multiply, and I'll do a conversion factor here. Now, what unit is going to go on the bottom of this first conversion factor? Not millimeters. Centiliters, yeah. Whatever unit was previously on top, that's the unit that has to go on the bottom. Centiliters was on top, now it has to go on the bottom. Now, what can I convert centiliters to? No, it's okay, man. We have to understand, conversion factors is probably one of the most difficult topics that you're going to cover in this entire semester. And the worst part about it is it's something that's going to come up in practically every chapter. So in some way, shape, or form. So it's going to be necessary for you to learn it well, but everybody struggles with this at first. Everybody struggles with this at first. And the more you work with it, the more you get comfortable with it. And y'all are gonna be champions before you know it. Right, so what unit goes on top? What can I convert centiliters to? I can't convert centiliters to milliliters because remember we had that same issue with the prefixes. I can't convert one prefix unit to another prefix unit, but I can convert the prefix unit to a base unit. So that means I could convert to, I think you mean liters, because the base unit here is liters, right? Yeah, no problem. All right, so then once again, I'm going to put a 1 in front of the prefix unit, 1 centiliter, and I'm going to put the meaning of the prefix in front of the base unit. Now, what does centi mean? What does centi mean? 10 to the negative 2, very good. Or 0.01, either is perfectly fine. I'm just going to use 0.01, but 10 to the negative 2 is absolutely correct. Okay, so now that I have liters here, I can convert to a more desired unit. The liters is of course going to have to come down, and what can I now convert liters to? What can I now convert liters to? What unit? Now milliliters. Yep, now milliliters. Absolutely, very good. And how many, and I put a 1 in front of milliliters. And then milli, as we already know, is 10 to the negative third, or 0.001. I'll just do 0.001 this time, but 10 to the negative third is fine as well. But we're not done yet because we're actually looking for the doses of medicine, right? So we have to do at least one more conversion. So I'm going to go ahead and the last conversion factor. Now, what unit's going to go on the bottom here? Milliliters, very good. And what unit goes on top? What can I convert milliliters to? Doses, very good. Absolutely, I can convert milliliters to dose. And how many milliliters does it take to equal a dose? Yep, you got it. So 5 milliliters, 5, whoops, 5 milliliters is equal to 1 dose. Notice that in each of these cases, the amount on the top of any conversion factor is equal to the amount on bottom. 1 dose is 5 milliliters. That comes right from here. 1 dose is 5 milliliters. 1 milliliter is 0.001 liters. The top is always equal to the bottom. So you can kind of check yourself with that. So now I just multiply everything on the bottom, multiplying everything on the top and divide by everything on the bottom. And if I do that, I'm going to end up with 6 doses. Well, dose is what I'm looking for. And see, here's the thing. What do you mean, why does dose go on top? You told me to put it on top. No. Yeah, no, dose has to go on top because we're looking for doses. We're looking for doses, and we're always trying to find what we're finally looking for should eventually go on top. But really, it's about what can we relate it to. We're always trying to map out a way to get from what we're starting with, in this case 3 centiliters, to what we're ending with, doses of medicine. So that's why I say follow the units first, because if we realize we have to cancel out centiliters and we think, well, what can I convert that to? I can only convert it to liters. And then to go, well, then liters has to cancel. What can I convert that to? Milliliters. Well, milliliters is not doses, so milliliter has to cancel out. And well, what can I convert milliliters to? And I see, oh, well, milliliters is related to doses, so that can go on top. So essentially, I'm trying to put together the pieces of the puzzle. I see what one end is, and I try to figure out what the other end looks like. But it's only once I have both units in the conversion factor that I can figure out the numbers. Because if you don't know what you're converting to, you're not going to know what numbers to put there. That's why I say always put the units first and then the numbers. And you're going to be in much better shape that way. Does that make sense? Okay, good, good. I know I felt like I got a little rambly there. Okay, so let's go ahead and take a look at another problem that I think is kind of cool. Let's do this. We're going to skip a couple of these, and let's go to the vehicle assembly building, number 8. The vehicle assembly building at the Kennedy Space Center in Florida has a volume of 3,666,500 meters cubed. Convert this volume to liters. So when you're dealing with cubic units, I don't want to do that. Undo that. Okay. So when you're dealing with cubic units, this gets a little bit trickier. And there's a couple of different ways to do this. And I'll show them both to you. Okay, so the first thing that we want to do is we want to start with the only number we really can. The only number we really can start with is the given number, the 3,666,500. The other thing that we can do is we can go ahead and start setting this up with a conversion factor. Now, I will say this, before you could really do this problem, you have to be aware of a very important conversion factor that you may or may not have memorized yet. But that conversion factor is this. 1 centimeter cubed is equal to 1 milliliter. Because scientists realize, and these are both metric units, by the way. Scientists realize that cubic units are a pain in the behind for measuring volume. because they're so hard to interconvert between one cubic unit and another. Plus, going from one cubic unit to another, you end up having like a ridiculously big jump in size from one unit to another if you're using cubic lengths. So instead, scientists decided to base it all on um, to invent this unit called the liter, and they said, well, 1 centimeter cubed, another basically a little cubic centimeter, is we're going to call that 1 milliliter. I'm actually going to draw it. Okay. You see my very sad artistic skills. Here's a little cubic centimeter, cm on all sides. Yeah. So that's our cute little cubic centimeter. Oh, thanks. um, so here's what we're going to do. What we're going to want to do here is we're going to want to convert. It's tricky to you might think we want to convert meters cubed to centimeters cubed, but that's not that easy, and I'll show you why. If you tried to do meters cubed to centimeters cubed, you'd end up with this little problem. If you tried to say, well, 1 centimeter cubed is just 10 to the negative 2 or 0.01 meters cubed, that would be wrong. And the reason is because of this little drawing that I drew down there. If I amp that up and draw a cubic meter instead, now let's do draw. Let's say I draw a bigger one here. Draw. Here we go. All right. There we go. Okay. Okay, so here's the thing. If I have a cubic meter, which you may not, 100 centimeters is equal to a meter. So 100 centimeters is equal to a meter. A cubic meter is 100 centimeters times 100 centimeters times 100 centimeters. So it's not 100 centimeters is equal to 1 meter cubed. 100 centimeters cubed is equal to 1 meter cubed. It's some sort of cube of that. So there's two ways to deal with this. I could say that 1 centimeter is equal to 0.01 meters, and instead of, what I would have to do is I'd have to copy this 3 times because I have to cancel out meters 3 times. There's meters cubed, so algebraically I have to divide it by meters 3 times to make it cancel out. And on top, centimeters times centimeters times centimeters gives me centimeters cubed. Okay. And if I do it like that, then I can convert centimeters cubed to milliliters, which I'll do now. 1 centimeter cubed is equal to 1 milliliter. And from there, I can convert milliliters to liters. And I'll go milliliters to 1 liter. Well, liters. And I can put 1 in front of milli, and then 0.001 in front of liters. I'll add the print over here. All right, there you go. So then you just multiply everything on top and divide by the bottom. And if you do that, you're going to get an obscenely large number. And once again, as we mentioned before, since these are all definition units, by definition, each one of these things are true. So these are all exact numbers. the number of sig figs in my final answer is going to be the same as the number of sig figs I started with. How many significant figures did I start with? Yeah, you have 5 significant figures. So I have to keep 5 significant figures in my answer. And to ask for it in scientific notation, I end up getting, well, initially I ended up getting 3, 666, 500, and then 000. That's what I end up getting initially. But if I want to convert this to scientific notation, I can basically take my, I'm going to do the, yeah, I'll use my little blue one. So here's my little dot for my imagined decimal point. And I have to shift this over 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 decimal places it has to be shifted over. So this is actually going to be, stop inking. This is actually going to end up being 3.6665 times 10 to the 9th liters. Does that make sense? Alternatively, if one wanted to, here we go. Oh, you know what? Your days are numbered, my friend. Bye-bye, centimeter cube. Okay, so now, alternatively, you could do the same type of process, but you could, instead of repeating the conversion factor 3 times, you could simply raise the entire conversion factor to the 3rd power. But some students find that more confusing, and I don't blame them. But you can really do whatever is easier for you. You end up getting the same answer either way. Cool? All right. So now, oh, what did I do? Okay. So we're gonna skip the old Exxon Valdez. I want to do one of these pharmacology ones with you because I think they're more fun. And here we go. Big eraser. Okay. Okay. So it said an individual suffering from high cholesterol in her blood has 232 milligrams of cholesterol per 100 milliliters of blood. If the total blood volume of the individual is 5.2 liters, how many grams of total blood cholesterol does the individual's body contain? Okay, so what number should I start with here? Where do I start? 232 milligrams of cholesterol per 100 milliliters? Okay. What do you think, Saffron? Do you agree or disagree? So one of you takes one answer, the other takes the other. So here's the deal. The question, how do we decide this, comes this answer here. How many grams of total blood cholesterol does the individual's body contain? Well, how much is in the entire individual's body? It, that would be the total blood volume, right? It'd be based on the total blood volume. So yeah, 5.2 liters. So you were absolutely right, Saffron. Good job. So 5.2 liters is what we start with. Now, this is what we're going to do then. We are going to go ahead and set up some conversion factors and see how we can solve this. Now, what unit goes on the bottom of this first conversion factor? Oh, Jonathan. Okay. All right. And then what unit goes on the top? A lol would be an interesting unit. Oh yeah, milliliters. Yep, there you go. There we go. Okay, so yeah, we have to convert liters to milliliters first. Now I'm going to do something interesting this time. I'm not actually going to put any numbers yet. I'm going to keep going. We know we have to convert liters to milliliters. Now we need to figure out what goes on the bottom of this next conversion factor. What can we convert milliliters to? All right, yep. Well, what goes on the bottom of the conversion factor, though? Ah, not milligrams. We need milliliters to cancel out. So milliliters has to cancel out. But then what goes on top? All right. Then take them out of town and finish the job. Shame on me. If you've ever seen The Emperor's New Groove, you'll know what that quote comes from. All right. Then we have milligrams, and that's milligrams of cholesterol. But we're looking for how many grams of total blood cholesterol. Grams of total blood cholesterol. So the next step, what units do I put? What unit do I put on the bottom? Milligrams, very good. And then on the top, grams, very good. All right. So now we have our entire process mapped out. All we have to do is put in the appropriate numbers. So for comparing milliliters to liters, well, how many milliliters are in a liter? I can put the 1 in front of the prefix unit and in front of liters. Close, Jonathan, close. And Haley, actually, you're not quite right either. 0.001, there we go. Yep. Centi is 0.01. Milli is 0.001 or 10 to the negative third. All right. Now, how many milligrams are there per milliliter? What unit goes on top and bottom? Or what number, rather? How many milligrams? 1 milligram. Not quite. There we go. 232 milligrams. Remember, what relates milligrams to milliliters is this phrase right here. 232 milligrams per 100 milliliters. It's okay, Saffron. You've been getting them right all night. Just bound you get one wrong once in a while. All right. So what? And then of course we have another milligram to gram conversion. So 1 milligram, and then 0.001 grams. And then all I have to do is multiply everything on top and divide by everything on bottom, and what do I get? Always, always, Jonathan. All right, so what do we get? What do we get for our final answer here? Very good, Saffron. Only one small thing. The unit's not milligrams. Grams. And your sig figs are wrong. Now, one thing I might recommend when you're calculating these, literally multiply everything on top and literally divide by everything on bottom. it is very easy to start messing things up in your calculations if you try to use parentheses or do all the tops first and then all the bottoms and then divide the total up from the top from the total on the bottom. Just literally type in 5.2 times 1 times 232 times 0.001 divided by 0.001 divided by 100 divided by 1, and then enter. And you'll get 12.064. But how many sig figs did we start with? Not 3. 2. Yeah, 5.2 is only 2 sig figs. So that means we only need 2 significant figures in our answer, and therefore our answer should only be 12 grams. Does that make sense? One thing I also want to make note of here is that, okay, so you got your definitional values here with the 1 milliliter over the 0.001 liters. But this one here is actually measured. Her cholesterol level is measured to be 232 milligrams per 100 milliliters. Now the 232 milligrams actually does have 3 significant figures. This is 3 sig figs. Okay? And you might be like, well, that 100 milliliters is only 1 sig fig. That's actually not quite true. This down here, which I'm going to actually underline in purple color, this is what's referred to as a reference value. When you have a lot of times when you have a fractional unit or conversion factor like this, one of the measured values will be compared to a reference value. And that reference value has unlimited significant figures. So it's like, for example, if you were traveling at 70 miles per hour, right? Miles per hour. If I wrote that as 70 miles over 1 hour, that would be its conversion factor form. But that 1 is a reference value. It doesn't inhibit your significant figures. Now the 70, if let's say I have a decimal point there, the 70 with the decimal point, of course, that would be 2 sig figs, but the 1 has unlimited significant figures because it is a reference value. So just something to keep in mind. So this, if I had like 5.247, that would be 4 sig figs to start. I would have still had to stop myself at 3 sig figs because of the 232 milligrams per 100 milliliters. But the 100 milliliters would not have dropped this to 1 significant figure. A little bit complicated, but does that make sense? Cool. All right, so one last question for y'all. Would you like to, say, do another practice problem? Try another one on your own, like say number 12, and then I can check it with you? Or have you had enough chemistry and would like to go do other things that are more fun? Okay, sounds good. You guys are troopers. All right, let's go ahead and take a stab at number 12. I'm going to actually let you work it out on your own. And when you're done, just go ahead and raise your hand. The little raise hand button is on the bottom middle of the screen. You'll see a little character with a little hand raise. Look at that. Raise your hand if you should. Okay, so click on that little guy that's next to the microphone symbol when you're done, or just say I got an answer, and then we'll check it together. I'll give you a few minutes. Okay, how are you doing? Coming along? Cool, cool. All right, I'll wait for you. Now you can also raise your hand if you give up. That's okay too, but it looks like Saffron's got it almost figured out. Oh my goodness. Jonathan, you weren't raising your hand to say that you actually have the answer ready, are you? Okay. Fair enough. All right. It was just funny. As soon as I mentioned you can raise your hand if you give up, it's like, no, it's totally understandable. This is actually a tough problem. This is a tough problem. This borderlines on the toughest problem that your professor would even think of giving you. Probably close to like the toughest problem your professor would think of giving you. You certainly would not get anything tougher than this from your professor. So if you can do this one, you're in good shape. But even if you can't do this one, don't feel too bad. This is a tough one. All right, we'll give a okay. You might have an answer. There you go. Last one standing. All right. You're you're the one we're depending on, Saffron. All right. Let's go ahead and let's get it going. Okay, so first of all, what did you start with here? Oh, what on earth? I don't want that. Okay. Okay, insert equation. Here we go. Uh, ah, what did we start with? We started with 34 pounds. Absolutely. So yes, you have to. You want to start with. It is possible to start with 115 milligrams per kilogram, but it's not ideal. It doesn't make as much sense, and it's a little bit more confusing. But interestingly enough, from a session I had the other night, a pharmacy tech basically said that they start with that he was taught to start with like the 115 milligrams per kilogram of body weight and work it the other way, which is honestly I find it a little bit more confusing. I mean I can do it, but I don't. It doesn't seem natural to me. But yes, in this case you have to start with the mass of the child because you have to. The amount of the dose is going to depend upon the child's mass. So 34 pounds and now we're going to multiply, and we're going to do conversion factor, multiply, conversion factor, multiply, conversion factor. All right, so the first one, and you went pounds on bottom, and what did you convert to, Saffron? What goes on top? Kilograms, excellent. Okay. So that would be kilograms, and I'm sure you did 1 kilogram is equal to 2.205 pounds, am I right? Or 2.2 pounds? Yep, that's what you used, correct? Oh, okay. Yeah, the English to metric conversion here, the table that I gave you, the table that I gave you at the beginning, has an English to metric conversion between kilograms and pounds. It's a little bit confusing, but yeah, you have to convert to kilograms first because the daily dose that's given, that was ordered by the doctor, is 115 milligrams per kilogram of body weight. So we need to go ahead and get kilograms of body weight before we can go any further. So what goes on the bottom of the next conversion factor then? Kilograms, and what goes on top? Yep, milligrams. Well, this is where it gets really tricky because you might be like, what? Don't I have to go to the base unit first? But no, because these are actually weights of two very different things. This is body weight kilograms, and this is milligrams of medicine. And you can't use a metric conversion to convert kilograms of body weight to milligrams of medicine unless you're chopping people up and giving them away as medicine, which would be weird and gross. But no, so we're gonna have to use. Yeah, yeah. Uh, so Yeah, we're going to have to use the milligram to kilogram body weight. So this is 115 milligrams of medicine for 1 kilogram of body weight. All right. So then we do another one here. Now, what goes on the bottom of the next conversion factor? There you go. Milligrams of medicine. And I'm going to have to convert the milligrams of medicine to what? Grams, exactly. Grams of medicine. And of course, this is just a metric conversion. 1 milligram is equal to 0.001 grams. And now that I have grams of medicine, I can convert grams of medicine to what? Milliliters, yeah. There's no way to get from grams to teaspoon, but yeah, I have to do grams to milliliters because if I look in the problem, you can see this density is a useful conversion. This combination, this is a useful conversion. And you have this as a conversion. So these are, sometimes it helps to actually isolate the conversion factors in your problem before you go. So we've already used, the tricky thing about this problem is that we have to use external conversion factors that come from like metric conversions or metric to English conversions. And then we have to use the internal conversions that are given in the context of the problem. This is an internal conversion. And the one that we're using here is going to be internal conversion as well. I have to convert the grams to milliliters, and it's 0.375 grams is equal to 1 milliliter. This is what I kind of referred to at the beginning as a situational conversion factor or a conditional conversion factor. It's only good for this situation, and only because the concentration of the solution happens to be 0.375 grams per milliliter. Okay, so now we can go ahead and do another conversion factor. Bum, bum, bum. We're not done. What unit's going to go on the bottom of this guy? There we go, milliliters. And what can I convert milliliters to? You got it, teaspoons. Very good. So I get 1 teaspoon is equal to roughly 5.0 milliliters. And and so I'm actually just going to highlight, just for fun, the conversion factors given in the problem. There were 3 given and 2 that you had to use that were not given. And that's one of the reasons that makes this such a challenging problem. But notice several things here. Almost every single one of these conversion factors has a measured value in it, and only one of them is a definition, which means it's an exact as unlimited sig figs. So this 2.205, that's 4 significant figures, and of course this is a reference value, so unlimited. This has 3 significant figures. This is a reference value, so that's unlimited, but this is 3. This is a definition, so this is unlimited. This is 3 significant figures, and this is your reference value. This is 2 significant figures, and this is your reference value. Now, if you're looking at all those numbers, and the number you started with, 34 pounds, is 2, 4, 3, 3, and 2. The lowest number of significant figures in any of those numbers that you multiply and divide is 2. So that means your answer is going to have 2 significant figures, which basically means it's the same as what you start with in this case. Sometimes it's good just to kind of double check your sig fig. Then if I multiply everything on top and I divide by everything on bottom, what do I get? Yep, you got it, Jonathan, 2 sig figs. Yep. Multiply everything on top, divide by the bottom, what do we get? 0.95. Yeah. 6.8. How'd you get that? Yeah, just multiply everything on top and divide by each thing on the bottom. I think it's possible you might have accidentally multiplied by one of the items on bottom instead of dividing. But yeah, so there we go, 0.95. Now in actuality, if you're a parent, chances are you're just going to measure out 1 teaspoon and give it to the child because they don't really have anything that measures 0.95 teaspoons. But indeed, they certainly are not. I like the Star Wars reference stuff. All right. Very cool. Well, thank you so much for coming. I hope this was helpful to y'all. Um, by the way, if you're interested in, oh, thank you. If you're interested in any of the answer key, any of the other problems, the answers for any of the other problems that uh, that this workshop covered, I'm actually going to go ahead and copy and paste this into the chat here. That's the complete answer key with all the work shown for all of the conversion factor problems. So you can check out any of the remaining problems on this particular uh, uh, practice practice set. Furthermore, um, if I haven't mentioned it before, I'm just going to go ahead and, oh, thank you. I'm glad. If I haven't mentioned this before, I'm actually going to do this real quick. Let me go ahead and pull this up real quick. I'm going to share my screen with you. So just in case you haven't heard it from me or someone else, we have a really awesome web resource site. If you Google or type into your chat, let's say I'll go to www.google.com, okay? If you Google or use any other search engine, you just type in TCC space SE space science, okay? It'll come up with TCC SE Science Learning Center. That's our Google site resource page. On here, if you click on Chemistry Web Resources, it'll have all the resources we have available to you. Now, I have a guilty admission to make. I have not built up the Chemistry 1405 course very substantially yet at all. However, the Chemistry 1406 course overlaps a lot with the Chemistry 1405 course. So I would definitely check this out, especially at the early chapters, because there's a lot of overlaps. So like, for example, practice problems, there's stuff over matter and measurement, conversions and such. Everything has an answer key included. There's going to be atoms and elements, ionic and covalent naming, compounds and their bonds, all that kind of stuff, isotope notation practice. Lots of really good stuff, and there's actually an entire video tutorial library as well. I am going to be starting to work on the 1405 stuff, but I have to confess I'm really busy this semester, so I don't know how fast I'll be able to develop that. However, if you just want to check out our workshops, our previous workshops, click on workshops and events and go to Chem 1405, and it has the video replay of our previous workshop, the outline and the PowerPoint, as well as the video, and then it also has this workshop, which is the workshop practice problems and the answer key for it. And I'll also have the video for this posted as well. I just have to do a few brief edits, and I'll be posting that probably sometime tomorrow. So anyway, all right, well, y'all take care, and feel free to let me know if there's anything else I can do to support you in your learning. Have a good night.